Hello everyone, in this video we're going to review the topic 1.7 to 1.11 rational functions. Alright, determine if the following rational functions have a horizontal asymptote, slant asymptote, or neither. Alright, now we need to review a little bit about the horizontal asymptote. Now if the degree on the numerator is less than the degree on the denominator, we have the horizontal asymptote y equals 0. Now if the degree on the numerator is equals the degree on the denominator, we have the horizontal asymptote, which is the quotient of the leading coefficient of the leading term in the numerator over the leading coefficient of the leading terms on the denominator. Now if the degree on the numerator is 1 unit greater than the degree on the denominator, we have the slant asymptote. Now look at example number 1. We see that the degree on the numerator is 2, degree on the denominator is 3. So 2 less than 3, we have the horizontal asymptote y equals 0, right? Second one, this one is 2, this one is 2, so it's going to be equals, right? We're going to take the leading terms right here. Alright, coefficient is going to be 1 and 3, so the horizontal asymptote is 1/3. Now number 3, this guy is 1 unit greater than this guy, right? So we have slant asymptote, right? Now question 4, this guy is 2 units greater than this guy, so this one should be neither. Now number 5, this one has power of 1, this guy has power of 1, this guy has power of 1, this guy has power of 1. So total this guy power of 2, right? This guy power of 2, so they are equals, right? Now you're going to check the leading coefficient, right? Leading coefficient is 2 and 3. 2 times 3 equals 6 over, this one is 1, this one is 1. 1 times 1 equals 1, right? So the horizontal asymptote y equals 6. Now question 6, degree of this one is going to be 3, this one 2, so total is going to be 5, right? This one 2, this one 5, total is going to be 7, right? So degree on the numerator is 2 units less than degree on the denominator. So you have the horizontal asymptote y equals 0, right? Now number 7, degree on the numerator is 4, degree on the denominator is this one 1, this one 2, so total 3, this is 4. So the degree on the numerator is 1 unit greater than degree on the denominator. So you have the slant asymptote, right? Now number 8, degree on the numerator is this one is 2, this one is 2, so total 4, right? 2 as power of 2 all together power of 2 is going to be as power of 4. Degree on the denominator is 2 and this one is 1, right? So it turns out to be 3, right? So the degree on the numerator is 1 unit greater than the degree on the denominator. So we have the slant asymptote, right? Now last one, degree on the numerator is as power of 0 right here, right? So it can be 0. Degree on the denominator is 1, right? So the degree on the numerator is 1 unit less than the degree on the denominator. So you have the horizontal asymptote y equals 0, right? Now, solve the following inequalities. Write your answer in the interval notation. So first, you need to find the 0 on the numerator and denominator, right? So you have s minus 2 equals 0. So s equals 2, right? Now second one, s plus 3 equals 0. So s equals -3, right? Now you're going to put this guy on the number line, right? So I have negative 3 go first, right? This one is 2, right? The right hand side you put positive infinity, the left hand side you put negative infinity, right? Right here you put 2 lines for me, right? Now you're gonna test the sign, right? So you're gonna pick a number within any interval, right? So I'm gonna pick 0 right here. I substitute into the inequality right here. Now I'm gonna check the sign, right? So 0 minus 2 is gonna be negative 2. 0 plus 3 is gonna be 3. So this guy actually negative, right? So I put negative sign right here. Now I check to see if this guy has the even multiplicity. And then this guy doesn't have any even multiplicity, so I keep changing the sign, right? So the sign should be alternating, right? So this is negative, this guy must be positive. This is negative, this guy must be positive, right? Now what I need to do is to find the interval where this inequality less than or equal to 0, right? So my interval should be this guy right here, right? Negative right here, right? So s, I put s right here, so s must be greater than negative 3 less than 2. Now I need to check to see if I'm gonna include the endpoints, right? So negative 3 right here is on the denominator, so I cannot include negative 3, right? Because if you include negative 3, it's gonna be undefined, right? Now 2 is a 0 on the numerator, so s equal 2, I substitute over here, it makes the whole thing equals 0, right? And I have the equal sign right here, so I need to include 2, right? So my final answer must be negative 3 comma 2. Right here I put a bracket, right? Now let's move on to number 11 right here. Alright, so I need to find the 0, right? So s plus 1 equals 0, so s equals negative 1, right? Now second one, s minus 3 equals 0, so s equals 3, right? Third one, s plus 5 equals 0, so s equals negative 5, right? Now be careful, s equals negative 1 right here has a multiplicity of 2, right? Alright, so now I'm gonna place this guy on the number line. I put 3 lines right here. Alright, now I'm gonna pick a number in this interval right here, 0, right? I'm gonna test for the sign, right? So 0 plus 1 is gonna be 1, right? 0 minus 3 is gonna be negative 3. 0 plus 5 is gonna be 5. So this guy is less than 0, right? So right here I put the negative side, right? Now I need to check the side right here. So I look for the 0 right here. This is 3. 3 has the multiplicity of 1, right? So the sign keeps changing, right? So this one positive. Now the 0 right here, negative 1. Okay, negative 1 right here has multiplicity of 2, right? So if a 0 has an even multiplicity, the sign stay, right? So this is negative sign, this is still negative sign, it doesn't change, so keep that in mind. Alright, so next one, 0 negative 5 right here has a multiplicity of 1, right? So the sign keeps changing. Alright, now finally I need to find the interval where the inequality greater than 0, right? So I don't include the endpoint, right? So greater than 0 is gonna be this guy right here and this guy right here, right? Because this positive and this positive, right? So I put s in the middle right here, so it should be greater than 3 less than infinity, and s right here should be greater than negative infinity less than negative 5, right? So I need to write this one in interval notation, so it should be negative infinity comma negative 5. Alright, I need to put parentheses because I don't see any equal sign right here, right? Union 3 to positive infinity, right? Now let's move on to the number 12. Alright, so I need to find the 0, right? So I have negative 3s equals 0, and then s equals 0, right? Next one, s minus 7 equals 0, and then s equals 7, right? Now next one, s plus 2 equals 0, and then s equals negative 2, right? Right, this one we have the multiplicity of 2, so you need to be careful with this guy. So we're going to put this guy on the number line, right? Now, the left hand side always negative infinitive. The right hand side always positive infinitive. Alright, so we have 3 0. It's going to be 0, 7, and negative 2, right? So negative 2 go first. 0 right here, and 7 right here, right? Alright, so I put the line right here. Alright, so now I'm going to pick a number within any interval and I'm going to test for the sign, right? So I'm going to pick 1 right here, right? Within 0 and 7. So I substitute over here. So I have negative 3 times 1 is going to be negative 3. 1 minus 7 is going to be negative 6, right? Over 1 plus 2 is going to be 3, right? So 3 squared. So this guy always positive, right? So we need to put positive side right here. Alright, now we're going to check for this one right here. 7. 7 has multiplicity of 1, right? So we need to change the sign. So it could be negative. Now 0 right here has a multiplicity of 1, right? So we need to keep changing the sign, right? Now x equal negative 2 right here has an even multiplicity right here, right? So you need to keep the sign, right? So this is negative, this guy must be negative. Alright, now finally we need to find the solution, right? So we need the inequality to be greater than or equals 0, right? So this one right here, greater than or equal to 0, right? That's it, right? So I put s in the middle right here. Alright, so s must be from greater than 0, less than 7. Now I'm going to check to see if I'm going to include the endpoint, right? So I have the equal sign right here. So any 0 on the numerator must be included, right? So I have s equals 0 right here. So I need to put equal sign right here. S equals 7 right here is on the numerator right here, right? So I need to put the equal sign right here. So finally I have 0, 7. Now number 13, we need to factor this one out, right? So s squared plus 3s minus 28. We're going to use s method. Alright, now a equals 1, b equals 3, and c equals negative 28, right? So we're going to put negative 28 right here, which is c, right? We put b right here, which is 3. Now we need to find two integers multiply equals negative 28 add up to 3, which is 7 and negative 4, right? So the top becomes s minus 4 times s plus 7. Alright, the bottom, we need to factor s out. So we have s minus 9 inside, right? Less than 0. Now we need to find the zeros, right? So we have s minus 4 equals 0. S equals 4, right? Now s plus 7 equals 0. S equals negative 7. Now s right here equals 0, right? The last one, s minus 9 equals 0. So s equals 9, right? Now we need to put all 0 on the number line, right? Now I'm going to pick a number within this interval right here. I pick 1. Alright, I substitute over here. Then I'm going to test for the sign, right? Alright, so I have 1 minus 4 is going to be negative 3. 1 plus 7 is going to be 8. 1 outside. 1 minus 9 is going to be negative 8. So this guy positive, right? So I'm going to put the plus sign right here. Now I'm going to check to see if there is an even multiplicity. So there's none, right? So I keep changing the sign, right? So this is positive, this must be negative, positive. This is positive, this guy must be negative, and this is positive, right? Now finally, I need the whole thing right here less than 0, right? So I need to pick the negative one, right? This one and this one. So my solution must be between negative 7 and 0 and 4 to 9, right? So it could be negative 7, 0. Now I look at this one, I don't see the equal sign, so I don't include the endpoint, right? So I put parentheses for this guy and this guy. Union 4 to 9, right? Alright, next one. For each of the following rational function, identify and label any value of s where the function has a hole. or vertical asymptote. Alright, now keep in mind, the vertical asymptote always dominates the whole. The whole dominates the zero. Alright, so keep that in mind. If the vertical asymptote and the whole occurs at the same time, the vertical asymptote dominates the wholes, right? So look at the number 14 right here. You see that x plus 4 and x plus 4, these guys are common factor on the numerator and denominator. So it should be cancelled out, right? So if you cancel out the common factor, this guy must be a whole, right? So a whole is s plus 4 equals 0, and then s equals negative 4, right? This is a whole. Now, the vertical asymptote is anything remaining on the denominator. So you only have s minus 1 left right here. So s minus 1 equals 0, and then s equals 1. This one is the vertical asymptote. This one is the whole. So keep that in mind. Now number 15, you have s minus 3 and s minus 3, you cancel out, right? So you only have s plus 2 over s minus 3 times s minus 8, right? Now look at this one right here. You just cancel out s minus 3 and s minus 3, right? This guy actually the vertical asymptote, right? Then s equals 3, right? And previously you cancel out this one and you say s equals 3 is a whole, right? But look at this one, vertical asymptote dominate the whole. So this one is vertical asymptote, right? There is no whole in this situation, right? Now another vertical asymptote, s minus 8 equals 0, and then s equals 8. Now let's move on to question number 16 right here. This guy and this guy cancel out, right? So we only have s minus 7 left on the numerator times s plus 1 over 2s, right? Now in this situation, the wholes and the zero occurs at the same time. The whole dominates the zero, right? So s equals 7 is not a zero. It must be a whole, right? So s minus 7 equals 0, and then s equals 7. This one is the whole. Now the vertical asymptote, you just let the denominator equal 0, right? So you have 2s equals 0. So s must be equal to 0, right? So this is the vertical asymptote. Now let's move on to number 17. We need to factor this one out, right? We're going to use S method for each of this one, right? So the first one, a equals 1, b equals negative 4, and c equals negative 12, right? So we need to find two number multiply equals c, which is negative 12, add up to negative 4, right? Which is b, right? Now it's going to be negative 6 and 2, right? So the top should be s minus 6 times s plus 2. Now the bottom, you still use the s method, right? Find two numbers that multiply equals 36 and add up to negative 12. It's gonna be negative 6 and negative 6, right? So the bottom should be s minus 6 times s minus 6, right? Alright, so we have s plus 2 over s minus 6, right? So you have s minus 6 equals 0, and then s equals 6. This one is the vertical asymptote. Now remember that you have a whole s equals 6. You have the vertical s equals 6. The vertical asymptote dominates the whole. So in this situation, you don't have the wholes anymore. You only have the vertical asymptote. So keep that in mind. Now let's move on to number 18. We need to factor the numerator. Alright, so a squared minus 9, we're going to use the formula a squared minus b squared equals a minus b times a plus b. Right, this one is the difference of square formula, right? So it's going to be s minus 3 times s plus 3. Right, because 9 right here you can write 9 as 3 squared, right? Now the denominator right here you just factor s out, so you have s squared plus s minus 6, right? Now you need to use the s method to factor each trinomial out, right? So you're gonna put c right here, it's gonna be negative 6. You're gonna put b right here, it's gonna be 1, right? Now you need to find two integers multiply equals negative 6 add up to 1, which is 3 and negative 2, right? So s squared plus s minus 6 can be written as s plus 3 times s minus 2, right? We cancel out s plus 3 and s plus 3 right here, so we have a whole s plus 3 equals 0, and then s equals negative 3, right? Now you have this guy and this guy on the denominator, so we have two vertical asymptotes. The first one is going to be s equals 0, right? The second one is going to be s minus 2 equals 0, and then s equals 2, right? Now let's move on to number 19. Alright, first we need to cancel out the numerator and denominator to find a whole if possible, right? So this one and this one cancel out. So we have s plus 3 power of 2 on the numerator, right? Denominator is going to be s minus 5 altogether squared, right? So because you cancel out this one, so s plus 3 equals 0 is a whole, right? So s equals negative 3. This one is a whole. Now second one, you have s minus 5 equals 0 because it's on the denominator, right? So you have s equals 5, and this is the vertical asymptote. Now, since you cancel out s minus 5 and s minus 5 right here, and you say this one is the whole. Yes, of course, but because you have the vertical asymptote and the whole occurs at the same time right here, right? So vertical asymptote dominates the whole, right? So in this situation, we don't have the wholes. We only have the vertical asymptote. Now let's move on to the next one. Write the equation of the horizontal or slant asymptote for each of the following rational functions. Alright, so we need to check for the degree on the numerator and the degree on the denominator. So since this guy and this guy have the same degree, right? We have the horizontal asymptote, right? So the horizontal asymptote is going to be the quotient of the leading term, right? The leading terms right here, right? So we have s squared over 3s squared. Now we cancel out s squared and s squared, so the answer must be 1/3, right? So y equals 1/3 is the horizontal asymptote. Now let's move on to the number 21, right? So the degree on the numerator is 3. Degree on the denominator is 4. So it's going to be 1 unit less than this one, right? So we have the horizontal asymptote y equals 0, right? Now number 22, degree on the numerator is 2, degree on the denominator is 1. So it's going to be 1 unit greater than this one, right? So we have the slant asymptote, right? Now in order to find the slant asymptote, we need to do long division, right? So we have 4s squared minus 3s plus 5 divided by s plus 2, right? Now if you want to review how to do long division and synthetic division, please check out the links in the description below, right? Alright, now 4 divided by 1 is going to be 4. S squared divided by S is going to be S. I'm going to multiply this guy back. So 4S times S is going to be 4S squared. Alright, I'm going to change the sign. It's going to be negative 4S. 4S times 2 is going to be 8S. I'm going to change this negative 8S. And then I do addition. Alright. So this one cancel out. Negative 3S plus negative 8S is going to be negative 11S. I'm going to print 5 down. Right. Now, next one. Negative 11 divided by 1 is going to be negative 11. S divided by S is going to be 1. So I don't need to write. Right. So I'm going to multiply this guy back. Negative 11 times 1S is going to be negative 11S. So I change the sign. It's going to be plus 11S. Negative 11 times 2 is going to be negative 22. So I need to change the sign. It's going to be plus 22. Right. Now I'm going to add this guy up. So this one cancel out. 22 plus 5 it could be 27. So this one can be written as h of s equals the quotient right here, 4s minus 11. Alright, the remainder right here, 27. So plus 27 divided by the divisor right here. So you need to put divisor as plus 2. Alright, finally, the slant asymptote is y equals 4s minus 11, which is the quotient. Alright, so keep that in mind. Now let's move on to number 23. Degree on the numerator is 3. Degree on the denominator is 2. So it can be 1 unit greater, right? So we have the slant asymptote, right? So we need to do long division again. Now the leading terms right here, s cubed, leading term right here, s squared. S cubed divided by s squared, it could be s. Now I'm going to multiply this guy back. S times s squared, it could be s cubed. I put s cubed right here. I need to change the sign. S times s could be s squared. I need to change the sign. It could be minus s squared. S times 3, it could be 3s. I need to change the sign. It could be negative 3s. Now I need to add them up. So this one cancel out. This guy add this guy, it could be negative 3s squared. 4s add negative 3s, it could be plus s, right? I need to bring this one down, minus 1, right? Now, the leading terms right here, negative 3s squared, divided by this one, it could be negative 3, right? Multiply this guy back, it could be negative 3s squared, so I need to change the sign, it should be plus 3s squared, right? Negative 3 times s, it could be negative 3s, I need to change the sign, it should be plus 3s. Negative 3 times 3, it could be negative 9. Change the sign, it could be plus 9. Right? Now I need to add them up. Alright, so I have this one cancel out. It could be 4s plus 8. Right? Now since the degree of the remainder right here is 1, less than the degree of the divisor right here. So I'm going to stop right here. Right? So my slant asymptote should be s minus 3, right? So y equals s minus 3 is the slant asymptote. Let's move on to number 24. Degree right here is 1. Degree right here is 1. Degree right here is 1. So total is 3. Degree on the bottom right here is 3. So the numerator and denominator have the same degree. So we have the horizontal asymptote only, right? Now the leading terms on the numerator is 2s times s times s, it could be s cubed. The leading terms on the denominator is s cubed only, right? Right here, s cubed. So it's gonna be 2. So y equals 2 is the horizontal asymptote. Now be careful with this guy right here. When you expand this one, now a lot of students make mistake. They say s minus 7 cubed equals s cubed minus 7 cubed. This is wrong. Alright, you need to get rid of this mistake. You need to apply the formula a minus b all together cubed equals a q minus 3a square b plus 3ab squared minus bq. Now let's move on to the example number 25. Degree on the numerator is 2 right here and 2 right here, total 4, right? This guy 2 and this guy 3, so total 5. So the degree on the numerator is less than degree on the denominator. We have the horizontal asymptotes. Y equals 0, right? Now let's move on to number 26. The graph of the rational function f is shown above. Which of the following could be an expression for f of s? Alright, so we look at this one, we see that there is a whole, right? So we need to write a fraction right here. A whole s equals 5, right? So you see that s equals 5. So then you need to convert this one into the factor, right? So subtract 5 both sides. So you have s minus 5 equals 0, right? So you have the factor s minus 5, right? So you put s minus 5 right here. You know that the whole occurs when the numerator and the denominator have the common factor, right? So you need to put s minus 5 on the denominator, right? Now you have the vertical asymptote right here. S equals 2, right? So you have s equals 2. Now convert this one into the factor. So subtract 2 both sides. So you have s minus 2 equals 0, right? So you put s minus 2 right here on the denominator, right? Now look at this one. You have the horizontal asymptote y equals 1, right? So since the horizontal asymptote y equals 1, which means the degree on the numerator and the degree on the denominator must be the same, right? So on the numerator right here, you only have this one power of 1, this is power of 1, this one power of 1. So we need one more factor right here so that the numerator and denominator have the same degree, right? So how do we find this one? Look at the 0 right here. 0 s equals negative 1, right? So we need to convert this one into the factor. So we have s plus 1 equals 0. So this is the factor right here. So we put s plus 1 right here, right? It's going to be b, right? Now, question number 27. The graph of the rational function k has a whole s equals 3. Vertical asymptote s equals negative 2. Which of the following could be k? Alright, so you have a whole right here. So you need to convert this one into the factors. So you need to subtract 3 both sides, right? So s minus 3 equals 0. So this is a factor. Now you need to convert this one into the factor too, right? So you need to add 2 both sides, right? So I have s plus 2 equals 0, right? Now vertical asymptote, so I need to put s plus 2 on the bottom, right? Now the wholes right here, s equals 3, right? So on the top and bottom must have s minus 3, right? Okay, now we're gonna check. We have a whole s minus 3. This could be right? This one wrong, right? This one has the whole s equals 3 right here. But this one doesn't have the vertical asymptote s equals negative 2, right? This is s plus 2, but this one s minus 2. So this one wrong. Now this one doesn't have a whole s equals 3, right? So this one wrong. So only A is correct. Now let's move on to number 28. Let the function g of s equals this one. Which of the following statements about g is correct? Alright. The graph of g has the vertical asymptote s equals 2. Now we need to simplify this one first, right? So this one cancel out. The top we have s minus 2 only, right? This one cancel out. The bottom we have s plus 1 square only, right? So in this situation, you don't have the vertical asymptote, right? You have a whole, right? So this one is wrong. Now question B, the graph of g has a vertical asymptote s equals negative 1, yes. And horizontal asymptote of y equals 2, no. because degree on the numerator is 1 unit less than degree on the denominator, you have the horizontal asymptote y equals 0, right? So this one is wrong. Now, question C, the graph of cheese had a vertical asymptote as s equals 2. No, vertical asymptote as s equals -1, right? So this one is wrong. Now, D, the graph of G has vertical asymptote as s equals -1 and horizontal asymptote of y equals 0. Yes, that's correct. Now, let's move on to the number 29. Let the function h of s equals s minus 2 power of 5 minus s to the 5th over 3 times s power 4. Which of the following statements about the graph of h is correct, right? So in order to do this one, you need to revisit the concept you learned before, which is the binomial theorem or Pascal triangle. Alright, so please check out the link in the description below to review the whole concept. Alright, so you see the power of 5 right here. You need to expand this one using the binomial theorem or Pascal triangle. Alright, so this is power of 5, which means row number 5. Right? Now, look at this one. You see the negative side right here. So you need to alternate the sign, right? First one is going to be positive, and then next negative, positive, negative, positive, and negative. Now, if you see the plus side right here, and then every single thing right here must be plus sign, right? Now we need to fill in the blank, right? The first term right here is s power of 5, right? So it can be s power of 5. The second term right here should be power of 0, right? So power of 0 we don't need to write, right? Next one, -5 times s power of 4, right? Remember that the exponent of the first term right here going down by 1 each times. The exponent of the second term right here going up by 1 each time. So keep that in mind. 2 power of 1, right? This one 10 times s power of 3 and 2 power of 2. Now keep in mind, you already put negative sign in front of this coefficient right here, so you don't need to print -2 inside right here, so be careful. Now -10 times s power of 2 times 2 power 3. Keep in mind, you need to add the exponent up to make sure they all equals 5 right here. Alright. Next one, 5 times s power of 1, 2 power of 4. And the last one, -1 times 2 power of 5. S power of 0, you don't need to write, right? Then you're gonna subtract s power of 5 right here, right? So I need to simplify this one. So this one cancel out. So the numerator only have this guy left, right? Over denominator, which is 3 times s power of 4, right? Now, I don't need to simplify this one because the question only asks you to find the horizontal asymptote, right? Now you look at the numerator and denominator to see the exponent are the same, right? So exponent right here 4, exponent right here is 4, so they are the same, right? So the leading term is going to be -5 s power 4 times 2, right? Over 3 times s power 4, right? Now I just simplify s power 4, so finally I have -10 over 3. This is my horizontal asymptote. So the answer must be D. Now let's move on to the last question. Let rs equals s squared plus s minus 6 over s cubed minus 5s squared plus 6s. Which of the following values of s are 0 on the graph of R? Alright, so we need to factor the numerator, right, and denominator. Now, to factor the numerator, you're going to use S method, right? You're going to put C right here and B right here. Find two numbers multiply equal C add up to B, right? A equal 1, B equal 1, and C equal -6, right? So it's going to be -6 right here, and B equals 1, right? So two numbers must be 3 and -2, right? So this guy becomes R of S equals s plus 3 times s minus 2, right? Denominator becomes, I'm going to factor s out first, right? So it could be s squared minus 5s plus 6, right? Now I'm going to use s method for this guy, right? So I put c equals 6 and b equals negative 5, right? So two numbers multiply equals 6 add up to negative 5, which is negative 2 and negative 3, right? So this guy turns out to be s times s minus 2 times s minus 3, right? So I put it over here, s times s minus 3 times s minus 2, right? Now I need to cancel out the common factor, right? So this one cancel out. So I only end up with s plus 3 over s times s minus 3, right? So you just let the numerator equal 0, right? So s plus 3 equals 0, s equals negative 3, right? So the answer must be B. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.